All right. So in this video, I wanted to take you through the concept of retrieval augmented generation with a vector store. And in the last video, I briefly talked about what is a semantic search using a vector store and why we generally need a RAG. So just to give you a recap, like we need RAG generally for two cases. So in some of the cases, you are asking questions to LLM which are beyond its cutoff training data date, like which is more recent happenings which are happening in this world. So in that case, your LLM won't be able to answer you, give you the correct answer. It will kind of hallucinate. And also, when your questions are very specific to a domain, so those domain-specific questions will also be not answered properly by the LLM. So in these two cases, we generally use the concept of RAG, and we plug in external data to the LLM to like reduce the hallucination, right? So without further delay, let's get started. So I will not only talk about the concept, I will also show you how to implement this RAG in terms of using LangChain and Llama 2. So let's get started. Just to give you a visualization, like a user comes with a question, so that question may not have the context, and those information, like the information that is required to answer this question, may not be available to the LLM, right? So this question without context gets passed to the LLM, and LLM kind of gives back an answer which is kind of a hallucinated answer, and it is not relevant to the question we are asking the LLM for the answer, right? So basically, for this case only, we wanted to use a concept of RAG, and we want to reduce the hallucination with the help of RAG. Like, so as we have seen in the last video, like we have a set of documents which can be very recent in nature, and also which can be very specific to a certain domain. And with that document, we kind of create text chunks. Then on those text chunks, we can use the embedding model to come up with the embeddings for those text chunks related to these documents. And then we kind of store these embeddings to a vector store, right? So this vector store will act as a knowledge base for the LLM. So knowledge base in terms of a particular domain or the recent happenings that are going inside this world. So all this information you can put through in this vector store, and that will kind of act as a plugin as additional data for the LLM, and then it can fetch those information using this vector store, right? So just to visualize this whole process, we have domain specific documents. Then using these documents, we kind of creates a chunk of documents, and on those chunks, using an embedding model, we populate the vector store, which is kind of a persistent DB where we kind of store these embeddings. And now a user comes, and that user comes with a question. That question may not have the context, right? So that question may be specific to a particular domain, or it can be a question which is very recent to the recent happenings to the world. And with those question, we will kind of create an embedding out of that question, and we will kind of do a nearest neighbor search on the vector store. It's kind of we are calculating the distance between my question embedding and also the embeddings that are present in the vector store, and we are trying to retrieve the nearest neighbor, and where the distance is minimum between the question and also the vector store information, right? And with that, we hope that we retrieve the domain specific context, and the question now has the context which has been retrieved from the vector store, and that will be this question along with the context will be passed to the Gen AI or the LLM model, and then LLM will produce better answers for these questions without context, right? Now that we incorporate the concept of vector store, and we retrieve the domain specific information, and now we have the question with the context, and that will kind of give the better or relevant answer to the question, right? So with this concept, let's see how it works in terms of code implementation, right? This is how the code implementation will look like. So we will start with very basic installation of required libraries. We also install the PyPDF, which is a kind of a document loader which we need for LangChain. And also we are using the sentence transformer for creating the embeddings of the document. And also we are installing the LangChain and ChromaDB, which are like the regular installations. So if I just give you a heads up, like what are the steps we have, at first we kind of load the domain-specific document. For our purpose, we are using a Llama 2 paper, which is kind of available in the Kaggle archive. And because Llama 2 was not trained with the information of Llama 2, right? Llama 2 specific information. So we are kind of using a domain-specific, Llama 2 specific document, and we are kind of creating a chunks and then storing in the vector store, and we will do a retrieve. We will try to do a retrieval augmented generation using this document. So once we load that document, we create chunks of those documents. So and on top of those chunks, we kind of create embeddings, and using a vector store, which is nothing but Chroma here, we will store those embeddings. And so at this embedding or this vector store which we are creating, that is kind of where we can do updates also, right? We can add the new informations which are coming. So that's one of the benefits of using RAG. Like we don't need to train the model multiple times, right? So we can use this retrieval augmented generation concept, and we can add new informations to the vector store and keep on adding those new informations to the vector store. And as we are plugging in this vector store to the LLM, your LLM will have the recent information or the domain specific information using this concept of RAG, right? So we will add additional documents to the vector store just to give you an understanding, like just to show you, like we can add also new documents to the vector store. Then we will perform like question answering using RAG on this documents, right? And we will use the Llama 2 to do this operations. So this is the path of my PDF file. So I am running this code inside Kaggle. So make sure you turn on your GPU when you are trying to access this code and trying to run this code. So at first I am loading this document, which we have also done in the last video. Then we are kind of creating text chunks, and we are creating the text chunks with a chunk overlap of 200. So there is a continuity between the chunks. And after that, we will create the embeddings out of this chunks. And we are using this Hugging Face model, Hugging Face embedding, which is using the model of sentence transformer. And then we are creating the embeddings. Once we have the embeddings, then what we will do is we will store these embeddings to ChromaDB. So you can just for your purpose, like I have mentioned, that you can also use OpenAI embeddings. And once you have the embeddings, then you will store those embeddings in the vector store or the vector database, and you can also persist that database to a particular folder in your system, right? And at a later point of time, you can load back that folder using this step, and it will kind of allow you to access the previously created embeddings, right? Now we can add back new documents to the vector store. This is like a new paper which I picked up from the archive. That is a survey of large language models paper that I have picked up, and that I have kind of added using these steps to my vector store, right? Now we will try to build a retrieval QA chain using Llama 2, right? So first of all, I am loading this model, which is nothing but Llama 2, a quantized version of that model that I am loading. And be patient, it takes around 25 minutes to load this model. So there are other ways, like you can use the blocks GPTQ version of Llama 2, which will be much more faster. That also you can try it out. Let me know if you want to see any of the video to how to quickly load the Llama 2 on your system. Then we are creating a pipeline, and using that pipeline, we are creating the LLM, which is the LLM model. And here, it's not that you can only use Llama 2, right? We can use any other model. So you can use the Google Palm model where the loading time would be much more faster. So this is, I have also commented out. So in case you want to use the Palm 2 model, you can use this in this way. Then I am passing my prompt, one of the prompt to the LLM. So this LLM still not being incorporated with the RAG, right? So I'm asking what are the two Llama 2 models released for general public for research and commercial use, right? So you can see it's kind of hallucinating and it's not giving me correct answers, right? Instead it's asking me questions on specific questions which I have asked for, right? Then what we are doing is we are implementing the RAG concept, and we are creating a retrieval QA chain. And inside that retrieval QA chain, we are passing our LLM. That we are also passing our knowledge base, right? So dv dot as retriever will incorporate the ChromaDB to this along with the LLM, and it will create a RAG system through which you can access, through which the LLM can access the knowledge base and can give you better answers, right? So if I just use the LLM without the RAG, and I ask like, what is so special about Llama 2, right? And it kind of hallucinates and gives you like vague answers, right? Like it tells you that llama is a type of animal, while Llama 2 is a software tool. Though it's mentioning a software tool, but it's kind of saying that Llama is an open source library for building scalable applications, while Llama 2 is more advanced version of additional features for improved performance. So it's kind of hallucinating and giving you a different kind of answer, right? Which is not relevant to what we are looking, because your Llama 2 training data set does not have the information related to Llama 2, right? So that's why using the RAG concept, we can improve this question and we can incorporate those knowledge. And you can see if I ask now this question, like what is so special about Llama 2, using the concept of RAG. So you'll see I will be using this RAG, which I have created this retrieval QA chain here. Using that, if I ask the same question, it kind of gives you better answers, and which are more related to LLM. And it also tells you like this model was developed by Facebook, and it has been trained on a large corpus. So with this, we can see like using the concept of RAG, we can eliminate a lot of hallucinations, and we can incorporate the recent data or the domain specific data as a plugin to the LLM, right? So I hope you like this video, and so this is all I had for this video. In case you haven't subscribed this channel, please subscribe. In case you like the content, please like and share this video with your friends and colleagues. Thank you all. Thanks for your time. See you in the next video. Thank you.